To solve equations by factoring, there are essentially 5 steps that you need to follow. Keep in mind that your polynomial equation should be quadratic in form, that is, ax squared plus bx plus c equals 0, in order to solve by factoring. The first step is to make sure your equation is in standard form. By standard form, we mean that the equation should equal 0. If the equation is not equal to 0, you may need to rewrite to make one side equal 0. Step 2 indicates to factor the polynomial. You can use any of the factoring techniques discussed in the previous videos. Choose the factoring technique that is appropriate for the given polynomial. Step 3 tells you to apply the zero factor property. This property says if two numbers have a product of 0, then this must mean that at least one of the numbers must be 0. In other words, if a times b equals 0, then either a equals 0 or b equals 0. Therefore, to use this property, you set each factor you obtain from step 2 equal to 0. Step 4 involves solving for the variable to obtain your solution. You take each equation you formed in step 3 and solve for the variable. Step 5 tells you how to check your answer. You simply take each solution and substitute it for the variable in the original equation, so to see if you get a true statement. If you get true, then you have the correct solution. In order to better understand how to solve polynomial equations, let's look at some examples. In example 1, we have the binomial 8x plus 3 times the binomial 2x plus 1, which equals 0. Notice in the example that steps 1 and 2 have already been done for you. This equation is set equal to 0, which means it is written in standard form. Also, the left side of the equation is the product of two binomials, which means this polynomial has already been factored. So we can proceed to step 3. In step 3, we apply the zero factor property. Basically, you take each factor of a binomial and set it equal to 0. Doing this will give you two equations. 8x plus 3 equals 0, and 2x plus 1 equals 0. Next, we carry out step 4, which is to solve each equation we got from the previous step. If we take the first equation, 8x plus 3 equals 0, we solve by subtracting 3 from both sides of the equation. Next, we divide both sides by 8. This gives us x equals negative 3/8. If we look at the second equation, 2x plus 1 equals 0, we solve by subtracting 1 from both sides of the equation. Next, we divide by 2. This gives us x equals minus 1/2. Therefore, we have two solutions, minus 3/8 and minus 1/2. Be sure to check your solutions by substituting them back in the original equation to see if you get a true statement. In example 2, we are given 3x squared minus x equals 4. In this case, the equation is not in standard form because it is equal to 4 instead of 0. So we will need to rewrite this equation. To do so, we subtract 4 from each side of the equation. This will give us 3x squared minus x minus 4 equals 0. Now the equation is in standard form because we have 0 on one side of the equation. Next, we carry out step 2, which is to factor the polynomial. In this case, we have 3 terms which we can factor by the no-fuss method. To review how this factoring technique works, watch the Factoring Polynomials video. Upon factoring, we get the binomial 3x minus 4 times the binomial x plus 1. Now we move on to step 3, which is to use the zero factor property. To do this, you take each binomial and set it equal to 0. This will give you two equations, 3x minus 4 equals 0 and x plus 1 equals 0. If we take the first equation, 3x minus 4 equals 0, we can solve by adding 4 to both sides of the equation. Next, we divide both sides by 3. This gives us x equals 4/3. If we look at the second equation, x plus 1 equals 0, we solve by subtracting 1 from both sides of the equation. This gives us x equals negative 1. Therefore, we have two solutions, 4/3 and negative 1. Again, be sure to check your solutions by substituting them back into the original equation to see if you get a true statement. In the next example, notice that we have a term missing. The equation has two terms in the polynomial. As you will see in a few minutes, this will affect how we factor. We still follow the same steps as before. Recall that step 1 is to make sure the equation is written in standard form. Since this equation is set equal to 0, this step has already been done. Next we do step 2, which is to factor. Since we now have a polynomial with two terms, we want to use a factoring technique that applies to two terms. For this we can use the greatest common factor, GCF. We see that the variable x is common to both terms, so we factor it out. This will give you x times the binomial x plus 12, which is still equal to 0. Next we apply step 3, which is to use the zero factor property. Notice in this case the two factors are x and the binomial x plus 12. So we set each equal to 0. This will give you x equals to 0 and x plus 12 equals to 0. Step 4 is to solve for x. Note that in the first equation, x equals 0, there is no need to solve because we are told that x equals 0. So we move on to the next equation, x plus 12 equals 0. To solve for x, we subtract 12 from both sides of the equation. This gives us x equals negative 12. Therefore, our two solutions are x equals 0 and x equals negative 12. Again, don't forget step 5, which is to check your solutions. In the next example, again, we have a missing term, so this will affect how we factor. We begin with step 1, which is to make sure the equation is in standard form. Note that this equation is set equal to 0, so that means step 1 has already been done for us. So we move on to step 2. In step 2, we need to factor the polynomial. Again, since we have two terms, we can try to see if we have a GCF. We can see that both terms have a common factor of 5, so we factor this out to give us 5 times the binomial x squared minus 16 equals 0. Notice that the binomial can be factored again using the difference of squares factoring technique. Applying this technique will give us 5 times the binomial x minus 4 times the binomial x plus 4, which still equals 0. Now we are ready for step 3, which is to apply the zero factor property. Note that even though we have three factors being multiplied, we only take the two binomials and set them equal to 0. We do this because the binomials are the ones that contain the variable x, which we are required to solve for. Doing this will give us the following two equations, x minus 4 equals 0 and x plus 4 equals 0. Now we are ready for step 4, which is to solve each equation for x. In the first equation, x minus 4 equals 0, and we add 4 to both sides of the equation to obtain x equals 4. In the second equation, x plus 4 equals 0, we subtract 4 from both sides of the equation to get x equals negative 4. Therefore, our two solutions are x equals 4 and x equals negative 4. Again, don't forget step 5, which is to check your solutions. For our next example, we are given an equation that has been factored somewhat, but is not in standard form. When this happens, we need to undo the factoring that has been done previously. To do this, we simply multiply the two binomials on the left side of the equation. Also notice on the right side of the equation, we can combine like terms, the 2 and the negative 10. This will give us x squared plus 4x minus 12 equals x minus 8. This equation is not in standard form because we need to see a 0 on one side of the equation. Since we only have two terms on the right side of the equation, it will be easier to get rid of these terms and make this side 0. To do this, we will need to subtract x from both sides of the equation and also add 8 to both sides. Doing this will give us the equation x squared plus 3x minus 4 equals 0. This equation is now in standard form. Step 2 is to factor the polynomial on the left side of the equation. Again, we have three terms which we can factor using the no fuss method. Upon factoring, we get the binomial x minus 1 times the binomial x plus 4, which equals 0. We are now ready for step 3. In step 3, we apply the zero factor property. Using this property will give us two equations, x minus 1 equals 0 and x plus 4 equals 0. For step 4, we solve each equation we obtained in step 3. If we take x minus 1 equals 0, we add 1 to both sides of the equation to get x equals 1. For the second equation, x plus 4 equals 0, we subtract 4 from both sides of the equation. This gives us x equals negative 4. Therefore, our two solutions are x equals 1 and x equals negative 4. Again, don't forget step 5, which is to check your solutions. In our last example, we have 3x raised to the third power plus x squared equals 4x. Notice that this equation is not quadratic because the largest exponent in the equation is 3. However, we can rewrite this equation and make it quadratic. This equation also is not in standard form. So we begin with step 1 first, which is to get this equation in standard form. To do this, we subtract 4x from both sides of the equation. This will give us the equation 3x to the third power plus x squared minus 4x equals 0. The equation is now in standard form. Step 2 is to factor the polynomial. Again, we have 3 terms, so we can use the no-fuss method to factor. However, notice that the 3 terms have a common factor of x. In other words, a GCF of x. So we factor the x out first, which gives us x times 3x squared plus x minus 4, which equals 0. Note that the polynomial in the parentheses is now quadratic, which we can factor using the no-fuss method. Doing so will give us x times the binomial 3x plus 4 times the binomial x minus 1, which equals 0. We now apply the zero factor property in step 3. Notice that we have 3 factors containing x that are being multiplied here. So when we apply the zero factor property, we'll end up with 3 equations. X equals 0, 3x plus 4 equals 0, and x minus 1 equals 0. In the first equation, there's no need to solve for x because we have that x is 0. In the second equation, 3x plus 4 equals 0. We subtract 4 from both sides of the equation and divide by 3. This gives us x equals negative 4/3. For the last equation, x minus 1 equals 0, we add 1 to both sides of the equation to obtain x equals 1. Therefore, we have 3 solutions: x equals 0, x equals negative 4/3, and x equals 1. Again, don't forget the last step, which is to check your solutions. You should look over the examples on the web page and then test your knowledge using Test Yourself.